Welcome to the Diagnostic Clinic. I am the strategist, your lead physician for today's masterclass. And right now, we are putting your Cambridge IGCSE Physics exam technique under the microscope. We are zeroing in on syllabus code 0625, topic 043, communications. Let me set the stakes for you right from the very first second of this explainer. Mastering satellite communication using microwaves, understanding how mobile phones operate, configuring Bluetooth using radio waves, mapping optical fibers, and totally nailing the distinction between digital and analog signals, this is absolutely not optional. It's not just a passing phase in the curriculum. This specific communications topic appears in every single examination series. You can bet your target grade it's going to be sitting there waiting for you. It is quite literally the heartbeat of the modern physics syllabus. Yet time and time again, year after year, I see incredibly bright candidates leaving crucial, easy marks behind on the table. Today, we put a stop to that. I am going to show you exactly what the examiners are desperately looking for. We are going to diagnose the specific symptoms of failing answers. We're going to examine two hypothetical students in our clinic today. We'll call them Alex and Sam, and we are going to prescribe the ultimate foolproof cure so that you can walk into that exam hall, open that paper, and secure absolutely every single mark available to you.
Now, this right here isn't just some helpful suggestion I came up with. This is an explicit, high-priority alert pulled straight from the Cambridge Principal Examiner reports. The quote reads, "The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario." I really want you to let that sink in for a moment. This single sentence explains exactly why brilliant, hardworking students end up losing marks. You could literally memorize the entire physics textbook front to back, you could know every single equation by heart, but if you walk in and treat the exam paper like a blank diary to just dump raw physics facts into, you will absolutely fail to capture those top A-star grades. Examiners are not testing your ability to act like a human encyclopedia and regurgitate information. They are testing your ability to apply that knowledge dynamically. When they ask you a question about optical fibers in the context of a broadband network, they do not want a generic, rehearsed essay on the speed of light. They want a targeted, precise diagnosis of the specific scenario sitting right in front of you. Context is absolutely everything.
Okay, let's dive into this. Our clinical roadmap today covers four crucial steps. Number 1, theoretical foundations. Number 2, the diagnosis. Number 3, our procedural framework. And number 4, critical analysis.
Moving right into Section 1, Theoretical Foundations, specifically looking at mapping communications.
So, the entire theoretical architecture of this communications topic rests heavily on precise definitions, clear causal relationships, and your ability to integrate this with other areas of the syllabus. You have to understand the whole system as a giant, interconnected puzzle, mapping out your knowledge flawlessly. Look at the table we have up right now. This brilliantly illustrates how you must link specific technologies to their corresponding wave types. On the left side, we have our technologies: satellites, Bluetooth, optical fibers. On the right side, the corresponding wave or signal type. You must link microwaves to satellites, you must link radio waves to Bluetooth, you must link optical fibers to cable TV and broadband. If you mix these pairings up in the exam room, the entire foundation of your answer just collapses. Think about the why behind it. Why do satellites use microwaves? Because microwaves have the specific frequency required to pass straight through the Earth's ionosphere without being reflected, allowing them to reach the satellite in orbit. Why does Bluetooth use radio waves? Because radio waves are absolutely ideal for short-range, local communication, and they can diffract around obstacles, meaning you don't need a direct line of sight between your phone and your headphones. You need to know these pairings flawlessly before you can even begin to formulate a top-tier analytical answer.
And before you can analyze any of the broader communication benefits of these systems, you absolutely must master the core technical distinction between digital and analog signals. Understanding this precise distinction is the absolute bedrock of evidence-based reasoning in this entire syllabus. Let's break it down simply. An analog signal varies continuously in both amplitude and frequency. It's a continuous wave with infinite possible values. A digital signal, however, is entirely different. It consists only of discrete values, just zeros and ones, high and low states, nothing in between. Now, the syllabus specifically requires you to know the benefits of digital signaling. And why is that so absolutely crucial? Because when a digital signal travels through miles and miles of an optical fiber and inevitably picks up background interference and noise, that noise can be easily and perfectly filtered out at the receiver. Because the receiver's only looking for those distinct zeros and ones, the signal can be perfectly regenerated to its original state. An analog signal, however, severely degrades over distance because when you put it through an amplifier to boost the signal, you literally amplify all the accumulated noise right along with it.
If you don't secure this fundamental, foundational definition in your mind, your later analysis of things like broadband systems will completely fall apart under the examiner's scrutiny. Let's shift gears to Section 2, the diagnosis. We are going to review the exact symptoms of a failing answer.
As your lead physician today, I am identifying the top 3 exam mistakes that are completely fatal to your final grade. Number 1, confusing cause and effect in communication systems. Number 2, forgetting format and presentation entirely. And number 3, giving generic, non-contextual answers. Let's bring in those 2 hypothetical students I mentioned earlier, Alex and Sam, to really illustrate this. Alex is a classic textbook case of the first and third symptoms. Alex panics and overloads the page with raw physics facts. If a question asks about the specific benefits of digital signals in modern mobile phones, Alex writes a whole dense page about how mobile phones were invented, what a microwave is, and the entire history of electromagnetic waves, completely ignoring the specific context of digital benefits. Sam, on the other hand, is a victim of symptom 2. Sam is watching the clock, rushes through the paper, completely misses the specific command word requirements, forgets to structure the answer logically, and just writes one massive, messy paragraph that the examiner simply cannot decode. Both of these brilliant students are leaving huge, massive marks on the table. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Now let's put their flawed, heavily red-penned approaches side by side on the operating table here. On the left, we have Alex's generic fact-dumping without any context. Notice how there are plenty of complicated physics words scattered around, but there is absolutely no logical progression. It is a total shotgun approach. Alex is just firing facts and desperately hoping something hits the target and gets a mark. On the right, we see Sam's rushed answer, completely missing any formatting. Sam's approach completely ignores the assessment objectives of the exam, which are specifically designed to target distinct cognitive domains, like your ability to apply and analyze data. Top students do not write like Alex or Sam. Top students structure their answers using a strict framework, specifically the PEAL framework, which stands for point, evidence, explanation, link. When you have a command word like explain or compare, you need structure. Neither Alex nor Sam is doing this. They are treating this Cambridge exam like a simple memory test instead of the rigorous analytical exercise it actually is. And as a result, they're losing out on the grades they actually deserve.
That brings us to Section 3, the procedural framework. This is where we pivot from diagnosing the problem to prescribing the cure.
I'm going to walk you through this strict, step-by-step, standardized sequence. This is the ultimate method mark strategy that guarantees you capture every single available process mark, transforming those red pen corrections into green check marks. Step 1. Deconstruct the question. You have to isolate the command word. Is the exam asking you to state, to explain, or to compare? Those words demand completely different things. Step 2. Extract relevant data. Pull the specific numbers, variables, or trends straight from the provided texts and tables. Don't guess, use the evidence they give you. Step 3. Select your analytical framework. Ask yourself, are you applying the principles of digital signaling here, or are you analyzing microwave transmission? Lock in your topic. Step 4. Execute the analysis with clear working and notation. This is where you deploy that PEAL framework we talked about. Make your point, back it up with evidence, provide your explanation, and link it back to the question. Step 5. Present with correct terminology. Ensure your final answer directly and beautifully addresses the specific scenario given. Systematic processing within communications requires this exact, unbending sequence. If you skip a step, if you jump straight to executing without deconstructing the command word, you will lose marks. It is that simple.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Moving into our final agenda item, Section 4, Critical Analysis and Evaluating Evidence. This is the highest level of assessment.
So, I pose this question to you. How do top-scoring candidates actually evaluate evidence? I want you to trigger a massive mindset shift right now. Stop thinking like a passive student who is just trying to remember what a textbook said. I need you to start thinking like an active, critical examiner who is marking a paper. When an examiner looks at your evaluation of a complex physics chart, say a data table comparing the efficiency of optical fibers to traditional copper broadband cables, what are they actually searching for in your writing? For our interactive workshop today, imagine a complex data source on the screen in front of you. If I gave you a 60-second visual countdown to extract the core trend, would you just read the numbers, or would you find the flaw in the system?
Evaluating evidence is about pushing past the obvious.
The crucial point you need to understand is that evaluating evidence isn't just stating facts, it's actively identifying limitations and alternative interpretations. Top-scoring candidates demonstrate true evaluative thinking by hitting these exact 4 bullet points. Number 1, questioning assumptions. Number 2, considering alternative perspectives. Number 3, identifying limitations. And number 4, justifying decisions with cold, hard evidence. Let's make this concrete. If the exam data shows that optical fibers carry vastly more information than copper wires, you do not just state that fact and move on. You justify it. You explain that optical fibers use visible light or infrared, which has a drastically higher frequency than the electrical signals running through a copper cable, and therefore allows for a much greater bandwidth of data. Then you identify the limitations. You show the examiner you see the whole picture by pointing out that the initial economic and infrastructural cost of installing fiber optic networks is significantly higher. That level of depth, that multi-layered analysis, is exactly what evaluative thinking looks like in practice, and it's what secures those top-tier grades.
Let's look at another incredibly critical skill for your interactive workshop, the massive difference between a mid-tier, average comparison and a top-tier, A-star comparison. Look at the 2 approaches here. On the left, the candidate is identifying similarities only. They might write a sentence like, both Bluetooth and mobile phones use electromagnetic waves. Now, that is completely true, but it's wildly incomplete. On the right, look at what the top candidate is doing. They are identifying similarities and differences, explicitly using comparative connectives to bridge their thoughts. They write, both technologies use electromagnetic waves. However, Bluetooth uses radio waves specifically for short-range local communication, whereas mobile phones utilize microwaves to communicate over much larger distances directly with cell towers. Do you see the difference? Using power connectives like whereas, however, and on the other hand actually forces your brain to structurally provide the contrasting evidence. True comparative analysis draws meaningful conclusions about relative importance by explicitly highlighting both sides of the coin.
Reaching 100% of your mark potential isn't some kind of exam magic or a stroke of luck. It happens predictably and consistently when you seamlessly blend your cross-topic knowledge, truly understanding how microwaves, radio waves, optical fibers, and digital versus analog signals all interact in the real world with the exact procedural framework we just laid out. It means ruthlessly applying the 3 rules that constitute our complete physics answering system. Rule 1, command word decoding. You must know what the question is asking. Rule 2, Peel framework application. Structure your thoughts methodically. Rule 3, time management matrix. You don't spend 20 minutes on a 2-mark question, you extract data from tables accurately, you interpret complex relationships, and you draw solid evidence-based conclusions. You absolutely do not dump facts onto the page like Alex, and you definitely do not rush the format like Sam. You take control, and you act as the lead physician of your own exam paper.
Let's wrap this up with our final checklist. Verify the context, apply the framework, and secure those method marks. Whenever you face a question on digital versus analog signals or satellite communications, always link every single point directly to the given scenario. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.